look at an example of solving kinematic equations in the x direction. So let's look at the x direction only. I don't see a coordinate system declared here, so we automatically start with a coordinate system. Let's declare to the right, which is x, positive x direction. Let's declare that as positive, and even though we're not going up or down, let's declare the positive y direction as up. So to the right and to up is positive. We declare it. We're given a sports car is traveling at constant speed. It passes the start line of a race and the driver immediately presses the brake constantly. The car comes to a complete stop 100 meters later in 5 seconds. We want to find deceleration. It's always a good idea to draw a picture. So here's our start line, and we have our car that passes the start line. We don't know its speed, so I'm just going to give it a V initial because we don't know it. And then it's going to travel 100 meters. Well, that's x final. That's that point right there. X initial is going to be 0 because we're going to start it out at the start line. So it's going to be 0 at the start line of x initial. And then we know it took a duration of 5 seconds. So the time it took is 5 seconds. And the last little bit of information that we're given is that the car came to a complete stop. So we know that V final is equal to 0. This is all the information that we're given. So we can fill this in. V initial is we don't know. V final is 0. T is 5. Oh, T initial is 0 seconds. And T final is 5 seconds. So we know that delta T is equal to T final minus T initial, which is equal to 5 minus 0 seconds, which is equal to 5 seconds. So now we know delta T. Let's go find out what we are. Oh, we have other information. X final is 100 meters. He has a very poor car. It took him a long time to stop. X initial is 0 meters. It took a long distance to stop. So delta X is X final minus X initial. And that is equal to 100 meters. So now we know delta X, we know delta T. So let's go look at our list of equations to find out what we can solve for. Well, what do we want to solve for? So we put a find up here, and we're really solving for acceleration. Whoops. We're solving for acceleration, even though we're decelerating. Accelerating means that the change in velocity is positive over time. Decelerating is the change in velocity is negative or decreasing over time. So we're solving for acceleration. And we are given X and we're given T. So this looks pretty good. We got a T here. We've got an X. We have a V final. We can solve for V initial. This would be a good one to use, but we want to solve for A. So what do we have here? Oh, we got V initial and A here, so we can't use this. We've got a V initial here. We can't use it. V initial here. We have A. So each one of these has V initial and A. So we have to solve for our V initial. So let's go ahead and use this third equation. V final squared is equal to V initial squared plus 2ax. And we need to solve for the initial velocity. So let's go ahead and Oh, we can't use this because we've got acceleration. So we need to go ahead and use the fourth equation. So delta x, let's use this fourth one. Delta x, which we know is 100 meters, that is equal to 1/2 v initial, which we don't know, plus v final. V final is 0, and the duration is 5 seconds. So now we can solve for this. So we need to multiply, this is this equation right here. We need to multiply both sides of the equation by a 2 and divide it by 5 seconds. So we have to do the same thing to this side. We want to multiply it by 2 and we want to divide it by 5 seconds. So 2 times 100 is 200. So we have 200. We just carry the meter through and we want to divide it by 5 seconds. And then we have 2 crosses out with 1/2. 5 seconds crosses out with 5 seconds, and we're only left with v initial on the right-hand side. 200 divided by 5, well, 5 goes into 20 4 times, so we have 40 here, and the units are meters per second. So now we know the initial speed, and notice the value is positive, therefore by our coordinate system, positive is to the right, so we can just say the object is going to the right, which is what we expect our v initial to be. So I'm not going to box it because it's not asking for that. It's asking for acceleration. Now we can go to another one of these equations. Let's go look at the first one. So let's choose the first one. And it says v final, which is 0, is equal to v initial, which is 40 meters per second, plus AT. And the time is 5 seconds. So we need to subtract A times 5 seconds to both sides of the equation. And we're left with a minus 5A, 5 seconds times A on the left-hand side, and that is equal to 40 meters per second on the right-hand side. So we need to divide by minus 5 seconds on both sides of the equation. So I'm going to divide it by minus 5 seconds. And we're left with A on the left-hand side of the equation. We have a negative sign here, so I'm just going to put it here. We've got 40 divided by 5. Well, I'm just going to leave it as 40 divided by 5 unless we calculate it out. So here's our Google calculator. 40 divided by 5 equals 8. And so we're left with 8 here. And our units are meters on the top divided by a second times a second, which is seconds squared. And the negative sign is telling us that the direction is opposite to the direction we declared, which is to the left, which makes sense. We're decelerating. And so that is our value. Minus 8 meters per second squared. And that's how we solve kinematic problems in the x direction.